They call it the Earth's crack. Because when you look down, you don't see the bottom. 625 meters of empty air. Wind speeds over 100 kilometers per hour. No safety net. This is the world's highest bridge crossing, one of the largest canyons on Earth. And China decided to build across it. 22,000 tons of steel, suspended above nothing. 3 years, $300 million. And at one point, the entire structure almost failed. January 2022, Guizhou Province, southwest China. Chief Engineer Liu Hao stands at the edge of an abyss. The assignment: build a bridge here. Over 626 meters of empty air. No flatland, no road access. Karst rock cliffs on both sides. Workers sleep in tents at the canyon's edge. Nothing but air between them and a 600-meter drop. Every single day. This is not an ordinary construction site. The terrain is so inaccessible that heavy transport vehicles can't deliver steel components in full size. 22,000 tons of steel, divided into 93 separate segments, carried piece by piece through mountain terrain. Guizhou now holds more of the world's highest bridges than any other region on Earth. Because the landscape demands it. Few people outside of China know this province. But engineering records are being set here. And here's the detail most people miss. GPS signals struggle inside deep canyons. So the project relied on Beidou, China's satellite navigation system. Millimeter precision, real-time positioning. Without it, alignment would have been impossible. But the greatest threat wasn't the depth below. It was the forces above. They had the plan. They had the technology. Now they had to stretch cables across a 1,400-meter wide canyon. You can't carry them by hand. A helicopter pulled the first pilot line across the void. Nearly a mile of open air. Then wire by wire, cable by cable. Until two massive main cables hung across the canyon, engineered to handle extraordinary loads. More than most suspension bridges ever require. But the wind never stops. At this height, gusts exceed 100 kilometers per hour. More than 200 stories above the canyon floor. No net, no second chance. Engineers deployed LiDAR systems to measure wind movement in real time. Dampers were installed to absorb vibrations before they could amplify. The cables held. Then the ground shifted. 17 geological fault zones beneath the foundations. Unstable rock layers. The solution required 200,000 tons of concrete, drilled 120 meters deep into stable bedrock. At that depth, it set a new construction benchmark for the region. The foundation stabilized. The structure could rise. January 2025. The final steel segment is locked into place. 93 of 93. $22,000 tons of steel suspended over open air. Comparable to the weight of a major skyscraper. And it holds. But static weight isn't enough. August 2025, 5 days. 96 heavy trucks. $3,300 tons of controlled load, simultaneously positioned across the deck. More stress than normal traffic would ever create. "400 sensors track movement in real time. Vibration, deflection, tension. The readings remain within international safety margins. Then comes official confirmation. Guinness World Records certifies 626 meters. The world's highest bridge. September 28, 2025. The bridge opens. A journey that once took 2 hours now takes 90 seconds. For local communities, that difference changes everything. A guesthouse owner who struggled for years with declining tourism records, 220,000 visitors during the first holiday period. Fully booked. Access changes economies. Isolation ends. Before the bridge, entire communities were separated by geography. Limited industry, limited tourism, limited opportunity. Younger generations left. Travel was slow and unpredictable. Now, two regions connect in seconds. In its first year, millions visit the canyon. Small businesses reopen. Former residents return. Not because of symbolism, but because infrastructure creates access. This structure rises 300 feet higher than One World Trade Center. Completed in 3 years for $300 million. In terrain once considered untouchable. 626 meters. 3 years. $300 million. A bridge suspended higher than most skyscrapers ever reach. Built in terrain once considered unreachable. For decades, this canyon divided entire communities. Now it connects them in 90 seconds. This isn't just about steel or concrete, it's about speed, precision, execution. Because in modern infrastructure, the real difference isn't whether something can be built. The real difference is how fast can it be done when the terrain says it shouldn't be possible.